Welcome to Pavitra Laptop Care. See, in any motherboard, you are able to see the coils. Correct. See, each coil give some particular voltages. Some may be fixed or some may be variable. The fixed are 3.35, 1.2 or 1.35 or 1.5 and 1.81 like that. Those are fixed one. Variable means it's a core voltages is 0.8 to 1.8 and so on. Sometimes 1, it's a 0.8 depending on the core. See, the main thing is we are giving 19.5 volts. See here the 19.5 volts we are giving to the high MOSFET. Here high low MOSFETs. Here the drain will receive 19.5 volts, but the source will give some voltages and the coil output will give the appropriate voltages. For example, let us check it's a 3.3. Okay, the thing is these two MOSFETs is controlled by this IC through the gate. Okay, like that. One more here, this IC will control these two MOSFETs and gives the appropriate output like 5 volts. And here just example I am giving, not exactly one. So this IC will control these high low MOSFETs and give the appropriate output, say 1.2 something. In some cases only the IC will receive direct 19.5 volts and it gives the appropriate output in the coil output. How it will calculate? Any idea? See, the thing is we are giving 19.5 volts but we are getting lesser voltage. This process is called PWM process, pulse width modulation process. Means, see, the thing is the time. For example, I am telling 1 minute per minute what the voltage will enter here. It's a pure 19 volts input. Pure 19 volts means it's a pure straight line. Okay, I'll give the exact information to you. See, I open the Excel here. See, this is 1 high. In case of this is the time period, the cycle we call. Cycle in the sense total 360 degree, how it will work. In case of it is a high, the time period. In case of pure DC, total time period will be 360 degree. The period is 1 minute. For example, I am taking 1 minute is too high. It's a nanoseconds it will take, or microseconds it will take. But the thing is, just for your understanding, I am taking it as a minute. Per minute, the duty cycle, the time period, what the time period the high MOSFET is on, that called it's a duty cycle. For example, completely it is a pure DC. In case of input is 19.5 volts. See what we got here. Here is the 19.5 volts. Then here is the duty cycle is 100%. In percentage we are calculating, right? The degree is 360 degree, but percentage is 100%. In case year to year 75% is on and 25% is off, that is a percentage. What the voltage you will get in case the per minute, this is the per minute, and again one more per minute, one more minute, the total minutes will count here. Per minute 75% if it is on, then what voltage we will get exactly, that calculation I am going to tell you in today's topic. See, now I told you this is called cycle. But what are the on position? This MOSFET, how long it will be in on? Actually internal MOSFET will be there. I will show you this high MOSFET. How long it will be on position and how long it will be off position. That's called, it's a time period. See the total time. The total time means how long a MOSFET is on and how long it will be off. The total period. Here is the on period and here is the off time. The total is time. Okay, here power has taken, but I will take it as a voltages. Okay, voltage I will take. So now the duty cycle, if it is 100%, what will be happen? It will happen 100% means it's a pure DC, 19.5 volts only we will get. In case, see, this coil will get 3.3 volts, correct? How it will calculate, what are the duty cycle of this? We will calculate exactly. in this Excel. See, in this Excel, simply I will tell you, this is seconds. 60 seconds is nothing but a minute, correct? For example, I am taking not exact one, okay? Here, per minute, the voltage is 19.5 volts in our laptop, okay? In case 1960 second the duty cycle is on, then our voltage will be 19.5 volts. Okay, 60 second if it is on, our voltage will be 19.5 volts. Okay, what about duty cycle? Duty cycle is 100%. See here, year to year complete straight line will be there. That is called duty cycle. Duty cycle will be 100%. The duty cycle formula is pulse width. See, it is a pulse width divided by time, total time into percentage. Okay, that's called duty cycle. Now we are calculating the seconds. How? Here is the formula. Here is the formula. You can see here. The thing is, in case we are getting what is that, 3.3 volts. Here 3.3 volts should come. Then how long it will be in on condition? For example, I will type 10 seconds. If the MOSFET, this MOSFET is on, the time period will be on in 10 seconds, the total duty cycle will be 16.6% and the voltage we will get 3.25. Understood? See, the duty cycle is on. This is the duty cycle. This pulse width, the total duty cycle is 16.6% and the voltage, average voltage we will get 3.25. Okay, in case 3.3, right? So in case that, in that case, if I type 11, 3.5, in case if we type 10.5, then 3.4 approximate, or 10.45 I'll type. 3.3 we got. Means the high MOSFET will be on till 10.49 seconds. Then only we will get the output 3.3. Okay, what about 5 volts? For example, this is the 5 volts. Then how long the high MOSFET will be in on position? This high MOSFET will be in on position. So the calculation is, for example, if we give 20, then 6.5, 15, 4.8, 16, 5.2 means 15.5. Yes, see, this MOSFET is on up to what? 25.83% duty cycle, and here is the voltage 5 volts it will give. In case the duty cycle will be 25%, this is the width. Okay, in case 100% means it will be heavy, but here is a 75%. Is 75% is also more. Okay, 50% also more, that also heavy, but here is a 25.8% duty cycle. The cycle means it's a on condition. If the MOSFET is on condition till 25%, then we will get 5 volts. Understood? Okay, 1.2 how? 8 volts, sorry, 8, it's a 2.6 is the 5 seconds, 1.6, 4, 1.3, 1 point, see, in case of 3 seconds it's a less, means 3 point something approximate. Okay, 3.4, yes, 3.45 something. That much of seconds if it is on, then this voltage we will get. The duty cycle will be 5. Only less, very less duty cycle. The average will be very less compared to main voltage. This is the main voltage 19.5, but average voltage will be 1.5 volts. Like this we will calculate the duration of the on condition of this particular MOSFET. Okay, but technically exactly some microseconds it will calculate. It calculated by this IC. So always one IC will control internally or externally high-low MOSFETs and gives the appropriate output. Okay, this is the calculation. Now you come to know what is the duty cycle and what is the time period and what exactly the voltage will comes, how long it will be in on position. Like that also I calculated as a seconds here, means 60 seconds I taken. For 60 seconds 19.5 means here it's a 3.4 seconds this voltage we will get. Understood? This time period, if it is on position 3.4 seconds, then the particular voltage will come. This is how we have to calculate the PWM voltages. Okay, if you have any doubts, so please put it in comment. For more information you can message me in Telegram, so complete details I will provide you. That's it. Thank you very much.